Hello students, this lecture is about how to measure current and voltage using a multimeter. Our objectives are to be able to follow good guidelines for the good use of a multimeter and to properly measure voltage and current using a multimeter. The multimeters we're going to use in class look like this. It is the DT830B digital multimeter. They're fairly simple, but they do everything we need them to do. I just want to point out two areas of this multimeter that we're going to be using most of all. This section called DCV stands for direct current voltage. This is the kind of current that's going to be coming out of our batteries, normal 1.5 volt batteries all the way up to much larger batteries. And this is the kind of battery we'll be using. So we're going to be using this section. You'll notice several different options within DCV. Starting from 200M, that stands for milli, so 1/1000th of a volt. This is just going to measure 200 millivolts at the maximum. And that goes all the way up over here to 1,000 volts. We could measure 1,000 volts with this digital multimeter. We're not going to be using anything nearly that high voltage. Almost everything we do is going to be using this setting right here, which is for anything between 0 and 20 volts. So we want this setting a lot. Off, of course, is very useful. It turns the multimeter off. And we're going to need this section over here. DCA stands for DC amperage or DC current. So we also want to be able to measure the current in a DC circuit. And we're going to mostly be using these last two settings down here. One is for 200 milliamps, and this is for 10 amps. So we could measure anything from 0 up to 10 amps of current on this setting right here. Over here on this side, you can see the ohm symbol. We'll learn a little bit more about that when we go into resistance in more detail. But basically these settings over here are going to allow us to be able to measure resistance. And we'll learn about that a little bit later. So let's learn how to measure voltage properly. Just write down these steps for now, and then I'm going to demonstrate what they are. So these should be going into your notes right now, so you have them for reference whenever we do labs. In order to measure voltage, you're going to plug in the black cable into the port labeled COM, and that stands for common. Down here, it's short for common ground. So we want to put, that's basically our negative side. And we want to put in the red cable into this this port. There's a port labeled V omega MA, and that port is right here, V omega MA. And we want to turn the dial to DC voltage 20, close the circuit, touch the red probe to the positive end of the component, black probe to the negative end of the component. We'll record whatever our measurement is in voltage and turn the dial back to off when complete. So pause the video if you have to get this down into your notes, because I'm going to demonstrate what this looks like right now. Okay, here is our multimeter. It looks like this, and it comes with a red cable and a black cable. And these cables have two different ends. One end has a right angle. This is the end that is going to plug into the multimeter itself. So if you remember, I need to plug in my black probe into COM, just like that. You notice the other end is pointy. It is a probe. We're going to be able to touch this to various components to be able to test voltage. Because they're sharp, we're going to want to be careful with these. Always put them down on a table when we're done with them. We put them away carefully. We will not be fencing with the multimeters at any time. We're going to take the red probe. In order to measure voltage, I want to plug the red probe into this port right here. You can see it says V omega MA. So the V is your reminder that it's for measuring voltage. And then we're ready to begin measuring voltage on some kind of a circuit. So if we go, we go here, we need to have a closed circuit that we're going to measure. So let me bring in a very simple circuit. So I have here a battery and a bulb in a bulb holder, and they're connected pretty straightforwardly. Let me turn off the overhead light, and you can see that the bulb lights up. So off, on. So my circuit is closed. Current is flowing from the positive end of the battery through the red wire, through the bulb, back through the black wire to the negative end of my battery. So I do have a complete circuit. If I want to measure the voltage across this light bulb, I need to turn my voltmeter on to DC 20. This means it's ready to measure anything from 0 to 20 volts. And what I do is I place the red probe on the positive side of the component. Positive side means the end that is most towards the positive end of the battery. Where's current coming from? I put the red probe there. And then I put the black probe on the other side. Oops. Red probe to where current is coming from. And I put the black probe on where current is going out of the component, back towards the battery. And you can see the voltage. So the voltage across this component is 1.46 volts. And that is, remember that a multimeter is going to be measuring a voltage difference. It's measuring a difference in the amount of energy per charge that electrons or charges have in this circuit. So the difference in voltage across this particular component is 1.46 volts. And let's not forget my last step, which is to turn the dial back to off when complete. So if I go back to my circuit, I want to make sure that my dial is back off. So I've turned my multimeter off. It's not going to be wasting its batteries. And let me disconnect this circuit right now so we can go back and learn about how to measure current. Okay, in order to measure current, we're going to be following these steps. What I'd like you to do is pause the video and make sure you get these steps into your notes so that you have them for reference whenever we do an electricity lab. I'm going to go ahead and demonstrate each of these steps right now. So here's my circuit. We'll notice it's the same circuit. I have a battery and a light bulb, and if I close the circuit, my bulb lights up, which is great. In order to measure current, I have to do a few things differently. It's not like measuring voltage. The few differences are these. The first step I need to do is make sure I change my red probe to be plugged into 10 ADC. Now I'm going to zoom in, and you can see that it's plugged into the 10 ADC port. Next, I don't turn it to the same place. I turn it over to 10 amps over there. So when I turn my dial to that setting, this multimeter is now ready to measure current anywhere from 0 to 10 amps of current. When I measure current, let's go back to step 4. I've completed steps 1 through 3. I've set up my multimeter. Step 4 is to make a gap in the circuit just before or after the component that I want to measure. The thing with measuring current is, unlike voltage, where we actually just placed our probes across the component, we can't do that to measure current. To measure current, we actually need to make the current pass through the multimeter. Otherwise, the multimeter doesn't know how much the current is. So in order to make current pass through the multimeter, we actually need to make a gap in the circuit. And I can make a gap one of two places. I could make a gap right before the component that I want to measure current through. There's actually a gap right here. There's a gap between this point and this point right here. There's my gap. Or I could make a gap right after the component that I want to measure current through. So there's a gap between the end of the light bulb and the wire that leads current away from the light bulb. So I'm going to choose to make the gap over here. I'm going to place my black probe on the negative side of the circuit. Current is returning to the battery that way. So that's where I'm putting my black probe. And I'm going to put my red probe to complete the circuit. And you'll notice that the bulb lights up again. The bulb lights up as soon as I touch the probe to the end here. And that's because current is now flowing again through this circuit, even though there's a gap here. There's no longer a gap in the circuit. The current is actually flowing through the bulb, all the way through the red wire, in through the multimeter, back out through the black probe, back through the black wire to the battery. So this actually makes a complete circuit, and now it gives me my current in amps. The units of currents are amps. So this is 0.22 amps through this circuit. Notice when I release the probe, the current goes to 0, or in this case almost 0, 0.01. So we have a little bit of a calibration issue with this multimeter. But closing the circuit allows current to flow through the multimeter, and now I can see that I have 0.22 amps of current. Now, because voltmeters and ammeters are often part of circuits, or I need to give you a circuit, I may need to give you a circuit diagram on a lab handout in order to show you where we want to measure current or measure voltage. They actually have their own symbols that we can put on a proper circuit diagram. The V, as you might have guessed, the V with a little circle around it, stands for a voltmeter. And if I have a simple circuit here where I have a battery, here's my battery, positive side is over here, wires, and this box, I've just drawn a box here to represent some component. Could be any resistor, could be a bulb, could be anything. Whatever this blank box is, if I want to measure the voltage across it, I need to put my voltmeter over here, and just like we did in the video, I need to place my probes on either side of it in order to get the voltage across that component. We say we are measuring the voltage across a component. Over here, the A with a circle through it in the circuit diagram represents an ammeter, or the multimeter acting to measure current. And we say we measure current through a circuit, because the ammeter actually has to be a part of the path that leads from positive to negative on the battery. It's measuring current through the path that it is a part of when it's right here. So this is how we draw it on a circuit diagram. This diagram would be great to add to your notes, as well as the statements that we just made, that voltage is measured across a component and current is measured through a component. If we can start to think about measurement of current and voltage in these terms, it's going to help you remember how you need to measure each of those, either across or through, when it comes to doing so in a lab or any other situation where you have to measure voltage and current. So let's go back to our objectives and recap. Following guidelines for good use of a multimeter, that was safety, being careful of the sharp probes at the end, always putting those probes down when you need to make a change to the circuit or do anything else. We're always turning our multimeter off when we're done making our measurement so that it doesn't waste the batteries. And we should also never touch the two probes together. We should never do that. So keep them well apart from each other. These are the guidelines for good use of a multimeter. Properly measuring voltage using a multimeter. Follow the steps. Make sure you have those in your notes so you're able to refer to them during a lab. And for current as well, we need to be able to measure both of these starting very soon in the labs we're going to do in this unit on electricity.